We have talked enough about providing reliability in networks. But when we talk about the transport layer, we specifically are interested in making our data transfer reliable. For that, TCP is incorporated. In this module, we'll see how does TCP provide data reliability, and is there a trade-off or a balance that TCP has to strike, because increased reliability might be putting a dent on the overall throughput that we wish to achieve. And then we are going to look at various reliability operations that TCP performs. These operations would give us good insight into the messages which take place in realizing TCP reliability when we implement it in Omnet++. So we agree that TCP does provide reliability, but it provides data reliability. In case the data, while being transmitted, is lost, it can be attributed to either the receiver side, the intermediate noise prevalence, or the behavior of the intermediate routers and their buffers overflowing. In either case, reliability is implemented through error control, flow, and congestion control. This reliability involves so many algorithms which are working together to implement reliable means. This will have a toll on the throughput that we wish to achieve. That is why people have often observed that equivalent to TCP that implements reliable services, UDP also offers services which are connectionless, which are unreliable, but they offer high throughput. That is why we see Skype and other audiovisual applications are based on UDP. So an expression that has been empirically computed, if we incorporate slow start and fast retransmit, fast recovery in TCP, we see that the throughput can be characterized by this simple mathematical relation, that is, it is 1.2 as a constant of proportionality, the maximum segment size divided by the round trip time. This gives us the bandwidth delay product. There is an expression in the denominator as the square root of the loss. This loss typically takes the value of 10 to the power minus 6, 10 to the power minus 9, but it can go as low as 10 to the power minus 10 for optical networks. So correspondingly, the throughput is going to be inversely proportional or affected with an increase in the loss. The reliability services which are offered by transport layer actually sit right below the application layer on top of the network layer. So the application layer takes no guarantees on providing reliability. Similar to it, the network layer takes no responsibility. So we see that transport layer as a reliable service sits between unreliable application layer and unreliable communication channel at the network layer. Let's look at the scenario where TCP implements the acknowledgement-based mechanism to prevent loss, to prevent the data loss because of packet loss. Here we see here that there is a segment which is sent from host A to host B. Acknowledgement is generated, but the acknowledgement gets lost. When this acknowledgement gets lost, the TCP sender times out and retransmits the same segment. Since the segment had earlier been received, so the segment would be discarded, but the acknowledgement would indeed be generated to prevent the sender from retransmitting once again. In case the round trip time estimation and the TCP timeout interval is not well adjusted, here we see that in one window, say 2 back-to-back segments are generated and their acknowledgements are generated, but the acknowledgements reach relatively late just because the TCP timer on the sending side has timed out rather quickly. So it is going to regenerate and retransmit the same segment. But since these two segments have already been received, an acknowledgement has been sent, so a cumulative ACK would be sent from the receiver side. If you imagine looking at all this transaction taking place in sequence charts, unless you are very clear about how TCP and its acknowledgement mechanisms work, you are likely to get confused. So beware of that. And this is a scenario in which The timer has been appropriately timed out, but the acknowledgement got lost for the first segment in the entire window. So the sender is going to have long enough timeout interval. Meanwhile, since the other segment has also been received, so a cumulative ACK is going to serve both for the transmitted segments.